this is my final project presentation from CIT 260. My name is Whitney Landon. I'm presenting my game, The Princess Bride Adventure. So the Java language has three main types of repetition statements: the for loop, which also includes a variation called the for each loop, the while loop, and the do while loop. Here's an example of the for loop. A for loop is where you use a counter to loop through a block of code a certain amount of time. So here we initialize our counter to 0. We want our counter to go to less than 4. So in that case, that's 0, 1, 2, 3, a total of 4 times. And we want our counter to increment up by 1 every time we go through the block of code. The while loop is where the program executes the block of code inside the while loop as long as the statement is true. So here, this statement is true, and then somewhere inside your block of code, the statement should become false. This can very easily become an infinite loop, so you need to make sure that somewhere the statement becomes false. The do while loop is similar to the while loop, except this time you perform the block of code at least once, and then you evaluate whether or not the statement is true. So in this case, we are setting up, we're getting input from the user and setting up an array. We want 5 words from the user. So if the selection array length is not 5, then we want this to continue through the loop. Here we have list processing. Java has 3 main types of list processing. The first, many other languages have, called arrays. Arrays are fixed length list of object or primitive values that can be changed during execution. Here we've defined an array called answer array. You need to define this data type, follow it by square brackets, and then put the variable name answer array to define an array. Here we initialize the array and fill it with words or strings. To reference an array, you use the index number. The index number is the number in order of the element. So here this would be element 0, the index would be 0, element 1, index would be 1. You can navigate through arrays by using the counter as the index number. So I start the counter at 0 where an index number starts at 0, and then I go up to the length of the array. You can also navigate through arrays using for each statements, and these statements just make it a little bit easier to navigate through arrays because they automatically go through every element of an array. Sometimes you don't want that, and so you would use a counter like we did in the last section, or other times you need the counter to reference something else. In this case, we need the counter to reference the index of another array as well. In the for each loop, it's for every element you perform this block of code. You can also have multi-dimensional arrays. This is a 2-dimensional array to defining, creating, initializing multi-dimensional arrays is very similar to a normal array. You just include 2 brackets. So to create a multi-dimensional array, you define the data type and then the number of rows and the number of columns. It's like having arrays within an array. To reference an array, you would reference both the row and column number, and you navigate through a multi-dimensional array in a very similar to a regular array by using nested for loops or for each loops. The first for or for each loop would reference the row, and the second, or the inner for or for each, would reference the column. And here you can see what we are we have defined a multidimensional array, created one, and then adding elements or initializing it to the array. Array list is a specific class that comes shipped with Java. This class is a variable length list, and objects can be added to it or removed dynamically, so during execution. Array list can only contain objects and not any primitive values. And so in order to put primitive values inside an array list, you need to box the primitive value inside a wrapper class and then unbox it when you need to use the value. Explicitly boxing and unboxing in Java is not necessary because Java Java has a feature called auto boxing, where Java automatically converts primitive values into its corresponding wrapper class object. And then the same thing with unboxing. It has auto unboxing. And defining an array list, you put the array list class name, and then in triangular brackets, the data type contained inside the array list. Like an array, the data type has to be the same throughout all the elements, and then the variable name of the specific array list. To add, get, set, or remove elements from array list, instead of using the index number and square brackets, you would use the specific methods that come with the array list class. Add, get, set, and remove. You can add them in the middle of an array list, at the end. You can get elements from array list using get. You can set elements, so change one of the elements in an array list to a different object. And you can also remove all the elements, remove a specific element, remove at a specific index. And you just need to use the specific methods that come with array list. You can navigate through elements, navigate through array lists similar to arrays by using for or for each loops. I don't have an example of array list because we didn't include any in our project. Enumerations are a special type of class used for fixed length lists of primitive objects, values or objects. These items are constant and they cannot be changed. So here we've created an enum class called scene. Enum elements are accessed by their keyword. So here in Nico's Grotto, all this green, those are keywords, and then inside these parentheses, they have values. Enum classes are similar to regular Java beans in that they have attributes and they have a constructor and getter methods. There are no setter methods because enums cannot be changed during execution, and so all its attributes are set in the constructor function, which is called whenever you the constructor function is called whenever you need to use a one of these keywords in this enum. You can navigate through an enum by putting the enum class name dot values, that turns it into an array. You can access the array index by putting the keyword dot ordinal, and then you can use a for or for each statement like any other array. Exception handling in Java gives the programmer a way to handle errors without suddenly terminating your program, and it also makes the code simpler because there's no need to explicitly check for errors every time you call a method. There are compile errors and runtime errors. Exception handling is used for runtime errors, and in this, we often use runtime try catch statements to catch exceptions. What you would do is whenever you have a method that could that could throw an error, you put a throw and then the error class, the exception class name, and then that is propagated up the class hierarchy by adding at the end of the signature, the class signatures, throws, and then the name of the exception. And then at the very end, you have a try catch statement that at the view layer. So here is, or at the end of your calling hierarchy. So here is an example of a try catch statement. You would perform the block of code inside the try statement or attempt to, and if an error is thrown, then the program executes this block of statement inside the catch statement. You can also use the finally statement, and that this block of code inside the finally is executed whether or not an error was thrown. Sometimes you need program-specific errors to be handled, and in which case you'd create custom exception classes. So here are examples of a custom class I've created called scene control exception. Is a number of constructors. Here we throw an instance of this class, and then here it's caught, and if the error is caught, then we call upon the display function in the error view class. Input and output streams are used to input and output to consoles, from keyboards to printers to files or from files. There are two different types of streams, byte streams and character streams. Byte streams are most useful for primitive values, and character streams are used for objects. Initially, to program, we use byte streams. This function system.in and these specific streams from input stream and from print stream, system.in to get from the keyboard, and system.out to write to a console, and system.error to write errors. These are replaced in our program by character streams, because character streams are modular and allow for internationalization in different languages. But we still use streams to write to files. And here we're writing to a file using the file output stream and the object output stream, and using the method .writeObject. And we're writing our game to save our game. And then we use file input stream and file object stream, an object input stream, to read from a file using .readObject. We use character streams, the class buffered reader, which is a subclass of reader, and print writer, which is a subclass of writer, to write to a console and to read from the keyboard. Here's some examples of that. We create a new buffered writer object, a new print writer object, and we're writing to a log in order to write errors. I'm sorry, not the log. We're writing to a console here to prompt the user for things or to explain things, and then we're getting input using .keyboard.readLine. Byte streams and character streams, regardless of which one you use, if you open a file, you need to close the file. That's often done using a try within resources statement. So here we have a try, and then we indicate which stream we're using. And that stream is automatically closed, and the file is closed at the end of the try block. So now I'm going to play a little bit of our game to illustrate some of the features of our game. So here we're playing the Princess Bride Adventure, and you play the character. Wesley plays in the movie, and you have to rescue Buttercup by moving through the challenges in the map. So yes, we would like to play the game. Whitney would like to rescue Princess Buttercup. Good luck. I'll start a new game. Here I want to view the map. Here we have our different scenes inside our map. Inigo's Grotto, Fezzik's Challenge, and Dizzy's Poison Puzzle. The rest of the scenes are blocked until these 3 scenes are completed, and different scenes open up as other ones are completed. So first I'd like to move to a new location. I want to go to Fezzik's Challenge. So row 0, column 1. We want to face Fezzik in a challenge of rock, paper, scissors, best 2 out of 3. I would like to accept this challenge. I'm going to select rock. It looks like he's played paper and won. I next want to play paper. He's played rock and lost. So now I want to play scissors. And as it turns out, Fezzik has played rock and he's won. The defeat menu displays. I just want to return to the game menu. I can also view inventory. So here I will view the inventory. We haven't won any challenges, so we haven't gained any inventory items. So the quantity of those is all 0. We can also print this inventory list. I'll print it to inventory.txt. If we look here in my files, we can see that it's been written. Quantity is still 0. There's a help menu. We can see we can reference these different things if we need help. Like if we want to remember the goal of the game, it'll explain the goal of the game again. And yeah, that's kind of that's game presentation. I hope that you enjoyed it and that it was informative.